welcome. And we're just before lunch, and between lunch and you is me talking about security, which is nice. Thank you for being here. Let's start right away because I've only got 20 minutes. DevSecOps, who have heard of that term? Who likes that term? That's what I thought. The first time I saw this word, it felt like a buzzword. Put it next to blockchain and AI, and you have full buzzword bingo, right? But think about it. What did we try to do with DevOps? Tearing down the wall between the old-fashioned silo of developers and the old-fashioned silo of operations, and somewhat mix that together that what we do is what we own and eat our own dog food. Pretty much, I tried to sum it up in one sentence, and Patrick would probably not agree with me fully, but hey. The thing is, security is not on our mindset yet. Security is still in many companies a silo. One security team, many engineering teams. How does that scale? Well, guess what? It doesn't. So, what are the problems? Basically, we're trying to solve a few things. Software delivery speeds up. Let me take you back to 15 years ago when I started as a developer. I'm a Java developer by trade. Yes, don't hold that against me. The thing is, I worked for the government, the Dutch government. I'm based in Amsterdam. We deployed 3 times a year, which is great because I have a lot of time to do things, and then people start testing it, pen testing it, doing all sorts of things before it goes into production. Then my previous job, before I joined Snyk, the company I work for now, I was working at basically the competitor of Amazon. Not AWS, but Amazon, the vending company. We deployed 3 times a day. How do you scale pen testing like that? You don't. But we need to be better, faster, and stronger, and we need to deploy faster to make sure that we are ahead of the competition. The thing is that there is a lack of security in that mindset because everything, look at your sprint board, Kanban board, or whatever you're using, it's a task like, if I click on this, I want it to be that. That's what your or your product manager does, right? The thing is, security is implicit, but implicit security for developers means, it's not my problem. In the end, it turns out that because security is siloed, it's an afterthought. We created something, it works on my machine, we ship it, works there as well, and then somebody comes up to me and says, hey, Brian, nice, but no. And the point is, we create friction. And the friction that we create is not good because I'm gonna hate my security team, and the security team is gonna hate my team because we are a bunch of cowboys. But in the end, we need to play the same game. We need to play the same role because we do not want to be yet the next big headline in the news because we were compromised. So, how bad is that situation? Well, I will give you one example. Well, one example later. First, if you think about security, the first things, if you go to a developer or a development team, they think about their code. The code that they put on GitHub or Git, or like the physical thing that they created. That's cool, but that's only 10 to 20%. Say I create an endpoint in my favorite language, Java. This is it. Look closely. What is wrong with that? Because I already created a mistake. Well, I will give you a hint. It's this. I have an input parameter in my endpoint, and without doing any validation nor sanitization, I write it to a response writer. You shouldn't do that because cross-site scripting. But how many of you got cross-site scripting or that kind of things in university or back at school or back in whatever you got your education? Probably not. Well, you can do code reviews. Sure, who does code reviews? The rest of you does pair programming? Fine, great. But you got me. And code reviews is like, hey, Junior in my team, we got 20 minutes left before the demo starts and we ship it. Can you please review it so we are confirming that at least 2 people looked at it? And we ship it anyway. Who is doing your code review? Is that code person the right person to do your code review? And why not plug in... No, why not put in tooling that helps you there? And not only in your CI pipeline, but while I am coding. In my IDE, or with the use of a CLI, or whatever. But no, we start coding, and in the end, hopefully we'll catch it, or not. And we find out years after the story. But again, that's only 10 to 20% of your application. The other 80 to 90% is things we borrow from the big bad internet, aka frameworks, libraries, dependencies. We pull them in and we use them because they do the heavy lifting for us for a good reason. I mean, I don't want to create yet another connection to my database. That's boring. I want to do the fun stuff or the stuff they pay me to do, not doing the boilerplate stuff. And that is fine. But look at the applications you create. Are you absolutely sure and are you certain? Are you aware of what is in your application? Exactly, to the point, to the letter of the code that you import. Probably not, because the framework puts in a library, puts in another library, transitive dependencies all the way down, and you end up with a bunch of stuff that you just use, you consume. Let's bring it back to 2017, because that's not that long ago. I could also bring you back to last year, aka Log4j, but that was boring. 2017, and you see the outline is a bit wrong, but it doesn't matter. Equifax. The problem was they built their application on a framework, Apache Struts 2. At a certain point in time, somebody found out there was an issue with Apache Struts. You think, fine, solve it, right? Well, the issue was found in March 2017. They didn't know. They were just getting the new sprint task, new feature, create it, ship it. In May of that same year, they got breached. The problem was that people were around in that system for 75, 76 somewhat days, snooping around, all sorts of things, and 140 million customers in the US were compromised because they were using the wrong version of that framework. It was already fixed. There was already a patch out. But it was in production, and we'll look at the new stuff. Let me get you to that problem. The thing that I needed to do, and was using Apache Struts, is just give a curl request with a specific header. This was the header. It's a content type. Who recognizes the content type? One person. That's cool. That means it is an invalid content type. It works this way. I use Apache Struts. It's an invalid content type, and it goes through a exceptional flow. In that exceptional flow, for some reason, I was allowed to utilize OGNL, the Object Graph Navigational Language, which is an expression language in Apache Struts. The thing is, with an expression language, I can create new objects or call methods on an object. I'm calling a process builder, so I'm spinning up a new process. I'm giving that process access to a bash. And if I do that, I can give it an arbitrary command. Basically, with this header, I can do arbitrary code execution or remote code execution by just curling this header and saying, in this case, hey, give me the environment variables. And you would say environment variables, boo-hoo. No, but I can also do a reverse shell with this, depending on what kind of user you're using. I am just consuming that library, that framework, and everything works fine. There's nothing wrong probably with my code, but because I'm using that, things can go wrong. You implicitly inherit these security issues. If this is your application, probably this is the code you wrote. And we take good care of that code because half of you were doing code reviews, the other half was doing pair programming, you said. Oh, I said that. Anyhow, how do you take care of that big yellow spot? Do you have some form of regulation in that? Do you update it? Or it's just like, hey, it works, ship it. If it doesn't break, let's keep it there. And you probably have in your company some application that's there deep down below, it works, nobody cares about it anymore. Well, cares about it, but nobody owns it anymore, and we don't dare to touch it. I worked at banks and insurance companies. Trust me, they are there. Open source use has exploded, but also people looking at that open source packages from the wrong angle, as in, what can I do with that to break it? And most of us are makers. Every year, new vulnerabilities get found in different ecosystems, so it doesn't matter. You can't blame Java in this case because it's the worst. But if you're working Node, Python, whatever, every ecosystem has that same issue. Most of these problems are not in the thing you pull in, but because the thing you pull in pulls in something else, several layers deep, somewhere deep down below, there is something that I might be able to exploit. And it's not that I have to find out. No, if somebody publishes it on the internet, or nowadays I just ask ChatGPT if there is an exploit, I just might get it. Thing is, if you ask the $1 billion question, who is responsible for security, this is the answer. We did this in our State of Open Source Security report that we wrote at Snyk, and it's a separation between developers, security, and operations. Where did that word DevSecOps come from, right? We need to do this all together and not just one team. If you look at code, the code created or the application created, then developers need to take their fair share because we want autonomy. The development team wants autonomy, wants to create things, wants to solve things, but you better be aware that that solution is also secure, not only fast and scalable and maintainable, yes, as well, but is it secure? And then you have your infrastructure, like your containers, or your infrastructure as code, or whatever you're using. So we talked about code, we talked about open source, and now we need to do environments. Well, hopefully not VMs, but say containers. Let's take a Docker container. In 2019, I did a small research on the 10 most commonly used Docker containers from Docker Hub and how many vulnerabilities were in there. Ta-da! Node was the worst one. And it wasn't Node that was the problem, because this was just the latest thing, because people are just pulling in from Ubuntu or from Node.js or from whatever without looking what's actually in there. That Node image was based at that point on Debian Jessie, full Debian Jessie. Do I need a full operating system for a small service? Probably not. What kind of things are in there? Do I need that? Probably not. Just use another tag might already help you. So we need to be aware of that, take a look at that, and also update. Because again, this is also a dependency. Comes with binaries. And maybe it might not be a direct hit to a problem, but it can be part in a chain of attacks. Hi. So we ask people, when you scan your Docker images, when do you scan your Docker images for open source or for operating system vulnerabilities? Well, 50% says we don't, and so some people do. I'm happy about that. And how do you find out about vulnerabilities that are already deployed in a container? A lot of people don't. So that is something that we need to do. Last thing is obviously your infrastructure as code. So basically, say your Kubernetes or Terraform or whatever you're using to orchestrate your stuff. Misconfigurations. That is one of the most, well, hideous problems that we fell into. And why not try to catch them before they hit the service, before they go into production? So what is the solution? I told you a bunch of problems. Solution is 3 things. Culture, process, and tooling. Culture means we need to want to work with this. Not like, hey, I'm a creator, I don't care. I've got a team that works for me. If you're a development team and you think like that, think it the other way. As in, if your manager is just breathing down your neck and saying, I want this feature today, what happens? You probably cut corners. You probably create technical debt. And in the end, you say like, yeah, they don't give me the time to get rid of that technical debt, and we cannot innovate anymore. Well, basically, if we are just pushing code and not helping our security team, we're doing the same thing. We need to own this as development teams. And we need to want this. Then you have process. Don't create new process, but put a process in place that doesn't block you, but enable you. We'll come to that in a second. And then we obviously need tooling to help us, because what is DevOps without tooling? So one of the things you can do, and this is a loaded term, you can create a security champions program. Woohoo! Well, what it actually means is this. Say you have one security team, you have a dozen engineering teams, that doesn't scale. We already agreed that. But say we put a liaison or somebody that is security agnostic inside that team. It's still a developer, but a developer that wants to be there. So we give him a badge. Hey, achievement unlocked. The thing is that if you distribute it like that, and you have a direct line between that security champion and the development team, you can still be autonomous to a certain extent. Like, there are a lot of issues that you just can't solve if there's somebody who knows what the policies are, what we need to do, what we can do, and into which boundaries we can move, and can check it, and is security agnostic, and can do the code reviews for some reason if it's security related. If we don't care about that and we don't put that in a team, then we still have the same thing. It's an afterthought. So how do you create such a team? I mean, this is easy. It sounds easy, but it's hard. It's very hard. The thing is that you need to be aware that these people want this. So, few steps how to create a security champion program. First of all, it needs to be developer focused. And I understand that with these small screens you cannot read everything, but it needs to be fully developer focused. Developer needs to want this. Preferably it's an opt-in situation. Ask them what kind of problem they need to solve. Why is security not on their mindset, and how can we enable them? How can we help them? Maybe it's time, maybe they don't know, maybe it's knowledge. It can be all sorts of things, but look at it from the developer side instead of, here are a list of defects, fix it. Nobody likes that. And what does the developer gain from that? We need to have executive sponsorship. That means all the way from up to the top, the CISO and the CTO need to agree that this is a thing. If somebody on that side says like, no, we need to ship that feature and I don't care about security anymore, or less, then it doesn't work, because that will fall down to the directors, to the VPs, to the directors, to the engineering teams themselves. So we need full support from everybody. And if there's no executive sponsorships, this will not work. So start there. Clear guardrails, as in we want autonomy. So give them the autonomy, give those teams the autonomy, and make sure that you say like, hey, between these things, like if it's a severity with a CVSS level lower than X, you can, if you have a good reason, you can ignore it. Or you can ship it, or you can deprioritize it. But if it's higher than this, we need to solve it right away. These are guardrails. And if there's not, then we have that security champion that can go back to the security teams. Because the next thing is there needs to be constant coaching and mentoring between that security champion and security teams. If there's a problem, I would go to my security champion and he needs to go maybe to the security team to say like, we have this edge case. How do we deal with that? Why? And most important, why? We need to encourage discussions on things that people understand it and not just comply. Because if there's one thing I hate, it's compliance. Because it's just ticking a box. If I understand why, I might do it, because then it makes sense. Last but not least, let's please reward the folks instead of punishing them. Hey, your team made sure that there were less vulnerabilities than the sprint before. Good job. Maybe that works in their ladder, as in how they can grow. If that is the way, instead of giving them only a list of defects and you did things wrong, you might even get adoption. And that is in the end what we want. For what is about the tooling, of course, the company I work for, Snyk, can help you. We have code capabilities that can scan your code. We've got open source capabilities that can scan your open source libraries and prioritize that for you. We have stuff that can check your container for issues. And of course, the infrastructure as code. I'm not going into the tooling. If you want to hear about the tooling, there will be a demo later on. But the thing is, you can use my tool, you can use somebody else's tool, but do it. If you have these tools, adopt them in the right way that you enable developers. That means not only in your pipeline. Pipelines are great, but if I can prevent to get that a vulnerability will get in, for instance, on my local machine, while I'm typing in my IDE, and my IDE says, computer says no, then I might already fix it right away. If I pull in a new library, how can I be sure that that library doesn't have already vulnerabilities? Because I'm looking at the functionality of a library, not how bad it is. But if it can help me, or I can scan it before I actually put it into my Git repository. Or if it lives in my Git repository, maybe I want to scan it over and over again, because what is safe today might be harmful tomorrow, because they found something. Your CI pipeline, yes, you still need that. And after that, you go to production, and you can choose if you want to block it or not if something goes wrong. My philosophy is don't block. Why? Let's speed up evolution and fix it in the next cycle. But hey, that's up to you. Once you're in production, and I see the outline here is again great, but the point is, if you are in production, you're not done yet. That happened to Equifax. At that point, they were not. They didn't have a problem. At the point of, say, November last year, nobody had a problem with Log4j. In December, everybody has a problem with Log4j if you were using that in an application. The thing is, you need to scan it over and over again. You need to redo this exercise. Because why not monitor it? I mean, things like your dependency tree or your Docker image container at that point when you push to production, that's stable. That is nothing that's not going to change anymore. But we know if we found something in that base image or in your dependencies. You want to know right away before something happens. So put stuff in place that ping you and help you prioritize that stuff. Again, we have tooling for that, but it starts with your mindset. Do it in all steps of the way. And a lot of people say we need to shift left. But security or software development is a development cycle, is a continuous process. There is no left in a continuous process because we don't do waterfall. We need to make sure that it's all the way, every step of the way, we have things enabled to catch it early and often, and that we have adoption from top to bottom, and that everybody is aligned on that. So, the three things were culture, process, and tooling. And that was my talk. Thank you so much for your attention.